Hello, and welcome to the course on failure analysis of electronic devices. I am Dr. Simard Normandin, President and founder of NewAnalysis. Let me introduce you to our half-day course. Whether you are designing an ASIC or a full system, the supply chain of electronic devices is large and complex, involving designers, component suppliers, board manufacturers, and assembly providers. When something goes wrong, identifying the failure mechanism isn't always straightforward. So this course is designed to help you understand the difference between failure modes and failure mechanisms. In this course, we will review a variety of tools and techniques used in failure analysis, explaining what each one does and the information it provides. This course is technical. It is intended for design engineers, component engineers, and quality engineers who may not be familiar with the underlying physics behind failure analysis tools. Whether you're dealing with customer returns, reliability failures, or supplier quality issues, this course will provide you with a solid foundation to tackle these challenges effectively. A bit about myself. I hold a bachelor's degree in physics from the Université de Montréal and a master's and a PhD in astronomy from the University of Toronto. After that, I did an industrial postdoctoral fellowship. That is how I transitioned to semiconductors. In 40 plus years of career, at 20 at Nortel and 22 at NewAnalysis, I have developed hands-on expertise in microelectronics, semiconductor device physics, reverse engineering, and electrical and material characterization. My publication record counts more than 50 papers and conference proceedings. In the last few years, I have delivered this course several times at conferences and on site at various companies. So let's dive into the course outline. We'll start with an introduction to the importance of failure analysis and the structure of 8D reports. We'll then explore the complexities of the supply chain, followed by a detailed explanation of failure modes versus failure mechanism. After that, we'll explore the tools of FA one by one. So let's go to the lab so we can take a peek at some of them. Failure analysis starts with visual inspection, for which you're going to need a variety of different microscopes. So this is a stereo zoom microscope. So the interesting thing about this microscope, it's relatively low magnification. It will take images up to 100 times magnification. But it has a very long working distance, which allows you to be able to take pictures by tilting your samples, and you get a lot of information this way. This is a metallurgical microscope. So it is, again, an optical microscope that is going to give you a color image. Such a microscope can go to very high magnification. With this one, we can go to above 1,000 times magnification in the image. But your sample must be very flat and very level to be able to obtain an image that is in focus everywhere. Okay. This camera is an infrared thermal camera, so it captures heat from devices. Of course, to have heat from devices, they have to be powered on. Its range of detection is in the infrared, maybe 5 to 20 microns in the infrared. It is difficult to mount on a microscope, but there are tricks that can be used. This one is a laser scanning microscope. So again, it is an optical microscope, but instead of using white light illumination, it uses a laser that is scanned over the sample. It gives you a digital image that has a lot of information, and there's a lot of information that you can extract from this image. We have two lasers, red and infrared. With the infrared, it allows you to look through most semiconductor devices. The microscope is also equipped with a full CCD camera, so we can capture light emission from devices when they are being powered on. That's why the light is very low, and that's why you have to keep your device in the dark when you take such types of images. So in the course, we're going to discuss all of these techniques to capture visual information from your devices. Once you have gathered all the non-destructive data that you need on your devices, you now need to verify the failure mode, particularly if it is an electrical failure. So you will need to prepare your sample for electrical test, and so we will discuss decapsulation, microprobing, liquid crystal analysis, emission microscopy from the front side, from the back side, also OBIC, OBIRCH, TIVA, all those techniques that apply mostly but not exclusively to integrated circuits. They are meant to reveal the location of the failures and nothing more. So here we have a probing station where you can put tiny little needles to be able to apply certain signal on your devices. And over there we have a less sophisticated probing station, but some devices, even components nowadays are so small that you may have to rely on a probing station to be able to measure them. Once you have localization of a defect, you may proceed to microsections and imaging. So first, back at the optical microscope, and then with the electron microscope. Here is an example of a resistor, and you see these tiny little flakes that have grown, and this resistor is actually now not working properly. So we will discuss plan view imaging, cross-section imaging, and EDX analysis. We will also touch on less common techniques, but useful techniques, such as FTIR spectroscopy, like this instrument that is behind me. We will also explain Raman spectroscopy, TEM, or transmission electron microscopy, SIMS, Auger electron spectroscopy, or AES, and XPS. We will make sense of all this alphabet soup. Concrete examples and case studies will be used throughout this course to illustrate how these techniques are applied in real-world scenarios. We'll cover failure analysis of discrete components such as power transistor, diodes, and LEDs. We will discuss spun wire failures, solder joint failures, issues specific to BGAs. We will also consider passive component examples and board-level issues. Finally, we will review how to identify counterfeit parts. I look forward to guiding you through this intricate and fascinating field. By the end of this course, you'll be equipped with the knowledge to analyze failure analysis in electronic devices, contribute to the reliability and success of your project. Thank you for joining me, and let's get started on this journey of discovery and in failure analysis. And don't forget to register.